What's up people, and welcome to my tutorial in Pragmatic Data Science. So in the previous video we made the first naive implementation of making a prediction from the data set that we have seen so far. We know that this floating point on temperature, it shows how many people he should be, bringing into the shop to help him out. But there is a problem with this data, and it is too simple. The model is too simple, basically. And if we have a look at the data, how it actually looks like the temperature on these days, we can see that intuitively this model might be too simplistic. So for example, if we take a look at some of the days here, how it actually looks like, we're solely basing it on the temperature. And this column doesn't contain the average temperature that we are using, but let's just take the temperature max here for simplicity's sake. So let's see, for example, this day right here, it has a pretty high average temperature. It has a maximum temperature of 91, which is almost 10 people that he's going to bring in. But if you take a look at the other parameters here, for example, the wind speed, you can see that on this particular day it was pretty windy. It was like almost 14 meter per second wind, which is quite a lot. And I don't think people are, going crazy for ice cream if it's like a hurricane out there. So they're gonna stay at home instead. So then he doesn't need to bring in 10 people, even though it's 91 Fahrenheit. So also some of these days you can see that. Let's see, for example, this day right here, you can see that it was, I mean, I wouldn't say that it was warm, but it was somewhat decent temperature here, and he's gonna bring in a couple of people to help him out. But on this day it was actually raining, and it was foggy as well. So it was foggy, and it was misty, and it was raining, and it was intuitively it was not an ice cream day, basically. And should he really bring in around six or eight people to help him out on this day? Probably not, right? So what we're gonna do now is we're gonna see how we can combine these things, because even though it was raining, as compared to if it was raining and cold, he should bring in more people, even though it was raining, than if it would also be in cold. So we need to combine them, basically. That's what I'm trying to say. So we need to consider more than one item, and we need to weight them, how much we consider them. And this is also why we do data normalization, to help us out with actually doing this like combination of parameters, so that it makes sense. So let me just explain this real simple. So we have this score variable here, and see here if I can spell score, and it's going to be equal to some floating point value between 0 to 1, right? And then we have the number of people that he maximum can call in, which is 10. And what we're going to do is we're going to take this score and we're going to multiply that by 10, right? And that is how we figure out how many people we should bring in, right? So what we're going to do here with the score is that we are going to smack some other parameters here that are also normalized. So this is going to look something like this, and I'm going to explain it in a while. So we're going to have a times x1 plus b times x2 plus c times x3, right? So what is this? This is multiplication and addition, right? So you can see them. I think it's nice to see them visually represented as three models or modules going on that contribute to the score here. The a, b, and c variables, these are constants, and when you sum up a, b, and c, they're going to equal 1. So a plus b plus c is going to be equal to 1. And what you can do basically is that you can have let's say 25, like this. A is equal to 25, and you can have b is equal to let's say is equal to 50, and C is going to be equal to, let's say, it's also going to be equal to 25 then, of course. So if you sum them up, it's going to be equal to 1. And you can redistribute this. So for example, you can say that, you know what, I'm not going to consider A so much. I'm only going to give it 20, right? But then you need to give those 5 extra points somewhere else. So this maybe becomes now 30, and it sums up to 1 again, right? Or 100. I mean, this is a floating point basically. It's going to sum up to 1. Sorry, like this. But you can think of them in terms of percentages, and I think of these constants as knobs that you can turn around like a switch or a slider, so you can determine how much weight you are going to put on this x value here. So what are the x values then? The x values are the measured values at that data point. And if we take a look at the data set here, an x value is going to be the temperature, for example. And an x value is going to be whether it's foggy or not, or it could be if it's raining or not, how much it was raining, so on. And this is going to be the x values, right? And the x values, they are also going to be normalized. All the x values are going to be somewhere between 0 and 1, a floating point. And that is why we need to normalize it in order for this to make sense, right? So what this is going to do, like, this is going to build up with linear combinations, a model set where you can define an arbitrary amount of new features. This is called features, by the way, all these like temperature and foggy mist, or these are called features. And you can like smack on arbitrarily large models here with more and more and more and more features, right? And make an infinitely complex model, that is gonna contribute to your score, right? And the score is always gonna be between 0 and 1, floating point, if you do it like this, so the constants always sum up to 1. So you get this score, and then you simply just multiply that with how many employees you can have. So this is the basic theory around it, and I hope you got that. And I also suggest that you can like test this out. Sometimes what I do when I just want to test something out real quick, I just open up a browser, I right click, and then I use inspect, and then I go to console here, and then I can see like what if I have score is equal to, I don't know, let's say that the weight for the first one is 20, and then I multiply it with the value, which might be 0.5, and then I the next one, we can take this example that I had here, and then the b was 0.5, so 0.5 times some value that we measured. Maybe it was pretty high, maybe it was 8, and then you take the last one, which was 0.3, and then you multiply that with some, let's take some pretty high value here, 0.9 as well. So now we get a score back. You can see the weight that I put on this, it got a pretty good score because the x values were pretty big. Let's see here also, some of these were higher than the others. So for example, the first model here, the weight wasn't so big on that one, so it was like only 20% is going to consider that. And here it's going to consider 60% of this model, and then it's going to consider 30% from this model or feature, the way you want to look at it. And then once you have the score, it's like you just multiply that, right? So this is a good way of just testing stuff out, basically, if you want to test something out real quick. And this was also why I put in the prerequisite that it will help you if you know JavaScript. But whatever. And that is all for this video. And the next one, I'm going to take a little bit more look into actually implementing this. All right, so I hope you guys enjoyed this, and I hope I didn't confuse you or anything. If you have any questions, leave it in the comment section, and don't forget to subscribe. See you in the next video. Bye-bye.